Now next part of the unit, this is ordinal utility. Approach. It is also called indifference curve approach. Ordinal utility or indifference curve. Okay. Cardinal was where we can measure utility by giving numbers. Ordinal means where we can measure utility by giving ranks. Ranks in the sense when you compare utility in different goods, that time we can give rank. Suppose a person prefer apple compared to mango. Means what? He is giving rank 1 to the apple and he is giving rank 2 to the mango. So when you compare different goods, that time we can give ranks. That time we cannot give numbers. So ordinal utility means those utility which we can measure by giving ranks. Now in ordinal utility approach, its another name is indifference curve approach. Now let us start with the indifference curve. Indifference means which is not different. Same. First we have indifference set. Indifference set means those combination of two good, those bundles of two good which can provide same satisfaction to the consumer. Those sets are called indifference set. Suppose for example, good X and good Y. Consumer is consuming two good X and good Y. Okay. Suppose he can consume like that 1 unit of good X, 5 unit of good X and 10 unit of good Y, 4 unit of good X, 12 unit of good Y, 3 unit of good X, 16 unit of good Y, 2 unit of good X, 20 unit of good Y. Suppose he is consuming these goods, and if all the combination provide him same satisfaction, means 5x and 10y, the satisfaction is provided to the consumer. Same satisfaction he is consuming if he consume 4 unit of x and 12 unit of y. Same satisfaction he is getting by consuming 3 unit of x, 16 unit of y. That time this combination is called indifference set. Means what? If the consumer choose any one bundle, suppose combinations are like that, A, B, C, D. If he choose any one combination from that, he will get same level of satisfaction. That time it is called indifference set. Means consumer is getting same level of satisfaction from any bundle, either combination A, B, C or D. This is indifference set. Those sets which provide same satisfaction to the consumer. Now if we plot this on the graph paper, if we plot this on the x-axis and y-axis, and if we plot a graph, we will get a convex shape of curve. This is called indifference curve. Okay, here we are measuring good x, here we are measuring good y. Okay, and if we plot the point 5, 10, 4, 12, 3, 16, you may check it in the graph paper, you will get this type of shape of a curve, convex shape. And this curve is called indifference curve. Means what? Indifference curves every point giving us same level of satisfaction. If the consumer lies at that point, whatever satisfaction you will get, same satisfaction you will get here, same here, same here, same here. So anywhere consumer may lie on the indifference curve, he will get same level of satisfaction. So indifference curve means that curve which each and every point provide same level of satisfaction to the consumer when he consume two good. Okay. Now this is called indifference curve. Okay. Now if we plot lot of indifference curve together, this is one indifference curve, this is another indifference curve, like that way lot of indifference curves are there. That time it is called indifference map. Indifference map. This is indifference curve 1, IC2, IC3, IC4, IC5, like that. When you plot more indifference curve in the same graph paper, then it is called indifference map. Lot of indifference curves are there. So indifference curve, this is indifference map. Okay. Now indifference curves property. What are the properties of indifference curves? First property is each and every point of an indifference curve shows equal level of satisfaction. Wherever the consumer lie, he will get same level of satisfaction. This is our first property. Same satisfaction. Second property is indifference curves are negatively sloped. Okay, this is downward or negatively sloped and convex to origin. Convex to origin. PPC you got in the earlier chapter, concave to origin, just reverse thing. Indifference curve is convex to origin. Third property is higher indifference curve shows higher satisfaction. Okay, in the same indifference curve we are getting same satisfaction, but if the consumer shift from one to another indifference curve, then you will get more satisfaction. For example, suppose this one, earlier suppose consumer was at that point, now whatever satisfaction he is getting, he will get more satisfaction in that indifference curve, because in this indifference curve IC1, this much of x, y and this much of x is consuming. But if we shift to the next indifference curve, without reducing the consumption of y, he can increase the consumption of x. So if the consumer move to the higher indifference curve, he will get more satisfaction. Fourth one is two indifference curve never touch or intersect. Okay, never touch or intersect means this type of situation will never arise. This is one indifference curve and this is another indifference curve. Two indifference curve intersect each other. This type of situation will never arise because the consumer always gets same satisfaction on the same indifference curve. If this intersect, this condition will not fulfill. We are coming it later. Why not two indifference curve intersect each other? So these are the main properties of indifference curve. Based on that, we can calculate consumer's equilibrium in ordinal utility approach. Now, consumer's budget. In ordinal utility approach, we require budget also. Now, budget means how much money consumer have in his pocket. Means how much he want to spend in the market. This is the budget. Suppose he want to purchase two good A and B. Now on that two good, how much he want to spend? This is consumer's budget. Okay. Now suppose consumer's budget is rupees 60. Budget is denoted by M. Rupees 60, and he is consuming two good. Good A, its price is suppose rupees 20 per unit, and good B, another good, its price is rupees 10 per unit. Okay. Now how he spent his money on the two good? Good A, good B. Good A is 20 per unit, rupees 20. Good B is rupees 10 per unit. And his budget we assumed earlier 60 rupees. Now if he spent the whole money on good A, good A price is 20 rupees, budget is 60 rupees, 60 divided by 20 means 3 unit. He can consume 3 unit of good A, but good B cannot consume because all the money is spent on good A. Okay, so 3 unit of A he can consume, good B is 0. Now if he reduce the consumption of good A from 3 to 2, means 40 rupees he will spend on good A, 20 rupees he will left in his hand. By this 20 rupees he can purchase 2 unit of good B. If he consume 1 unit of A, that time he can consume 4 unit of good B. If he don't consume A, then all the money he can spend on good B, then 60 divided by 10 means 6 unit of good B he can consume. It means what? It means the expenditure of the consumer on two different goods. Like that way he can spend. According to requirement, he can purchase 3 unit of A or 0 unit of B, 2 unit of A, 2 unit of B, like that. So this is the combination of two goods which he can purchase through spending 60 rupees in the market. Okay. This is called budget set. A, B, C, D. These are the budget set. So budget set means different combination of two goods which the consumer can purchase. He can purchase like that way. This is budget set. These are the three budget combination which he can purchase through spending rupees 60 on good A, good B. Now if we plot these two on the graph paper, that time we will get budget line. Here we are measuring good A, here we are measuring good B. And if we plot this point, we will get this type of shape of a curve. It will always straight line. And this one is called budget line. If we plot it like that way. Budget line is denoted by symbol is M and N. This is budget line. If we plot all these points on the graph paper, then you will get like that. First one is 0, 6. X-axis 0, Y-axis 6. This point is 0, 6. And this point is 3, 0. And in between the other 2 points, 2, 2 is the another point, 1, 4 is another point. If we plot, we will get this type of a curve. This is called budget line. Budget line is downward sloping. Why for? Because if we increase consumption of a good, we have to reduce consumption of another. Because our budget is fixed, we assumed. In fixed budget, we cannot increase both the consumption simultaneously. If we increase consumption of a good, we have to reduce another. So, negative relation between the two good in consumption, that time budget line is downward sloping. Okay. So, this is our budget line. Now, when the budget line can shift? When we can shift the budget line? Budget line generally shift when our income changes or price of the good changes. Okay. This is our normal budget line. M, N are the common budget, normal budget line. Okay. Now, if consumer's income increases, that time what happens? He can increase the consumption of both the goods simultaneously. That time budget line will shift towards right side. This is the one concept. If his income rises, if income of the consumer increases, that time budget line will shift towards side. Or another thing, if the price of both the good decreases, earlier it was rupees 10 per unit or 20 per unit, if both the price decreases, suppose it become 8, it become 15, that time with the same budget, he can increase consumption of both the goods. So, if price of X also decreases and price of Y also decreases, that time also budget line will shift towards right side. Just reverse thing. If the consumer's income decreases, that time budget line will shift backward. His income was 60 rupees. If his income decreases or budget decreases to 40 rupees, then he has to reduce the consumption of both the goods. That time budget line will shift towards back side. Opposite thing, if the price of both the good increases from 10 to 20, if it increases to another price, that time also budget line shift towards back. Because with the same income, he cannot consume the same good as earlier because price increases. So budget line shifts due to change in the income and price of both the good. That time budget line shifts either right side or budget line will shift towards left side. Now, where the consumer reach in equilibrium? How consumer reach in equilibrium? We get earlier indifference map. Suppose these are the three indifference curves, IC2, IC1, IC3. This is good A, This is good B. Okay. We learned in the property of indifference curve that higher indifference curve indicate higher level of satisfaction. If we shift from IC1 to IC2, you will get more satisfaction. If we shift to another one, you will get extra satisfaction. If we shift to IC4, then you will get some more satisfaction, like that. Now, where he will stop himself means where he will reach in the equilibrium. Okay. Now, where he will reach the equilibrium, where his budget permit. Okay. Suppose this is the budget line. Mn is the budget line. Means what? He cannot consume beyond his budget line because this is non-attainable bundle. Suppose from that point, this point is more suitable for him, or more good quality of commodities are available here, or more satisfaction is available here, but he cannot reach here because his budget is up to here. So this point is his maximum satisfaction level on the basis of his budget. So this is consumer's equilibrium point. Okay, so at equilibrium, two conditions we have to satisfy in the ordinary utility approach. What are the two conditions? In that point, IC must be convex to the origin, and budget line must become tangent with the indifference curve. Budget line must be tangent with the indifference curve. Here the budget line become tangent with the indifference curve. So these are the two conditions for consumer's equilibrium in case of ordinary utility approach. First condition, at the equilibrium point, IC must be convex to the origin. Second condition, at the equilibrium point, budget line must be tangent with the indifference curve. So this is the equilibrium point where he can get maximum satisfaction through spending his income, and he will come back home through consuming this much of good B and this much of good A. Okay. Now another interesting point, he can consume at this point also within the budget. He can also consume at this point also. He can consume at this point also, because these two are also within the budget line. G and F also within the budget line, but he is reaching equilibrium at E. Because of why? Because G is lower indifference curve. G lie on the lower indifference curve, IC2. So through spending same amount of money, why he will take less utility? He will try what? Consumer's target is to reach maximum satisfaction. We learned earlier. So through spending same amount of money, why he will get less utility? So he will not be equilibrium at G or F or any other point on the budget line except E, because only at E he is getting maximum satisfaction. He can purchase any other on the other point also on the budget line, because other point provide him less satisfaction compared to E. So E is the maximum level of satisfaction, so he will reach in equilibrium at point E. So according to ordinary utility approach, consumer reaches in equilibrium at that level where his budget line becomes tangent with a particular indifference curve. Now two important concepts. Why? First one, why ICs are downward or negatively sloped. This is the shape of the indifference curve. ICs are downward sloping. Why downward sloping? Because we get what? Every point on an IC same satisfaction. So if we want to increase the satisfaction on one good, suppose earlier consumer was at that point, that time what happened? He can consume this much amount of X, Y, and this much amount of quantity of good X. Okay. Now if we want to increase the consumption satisfaction from X, suppose he is reaching here, then what happened? If we want to get more satisfaction from X, he have to reduce the satisfaction of Y. Means what? There is opposite relation between the satisfaction of both the good. If we want to get more satisfaction from one good, we have to reduce satisfaction from another good, if we want to maintain same level of satisfaction. So what we are saying, if we increase one good, we have to reduce another good. Means what? Opposite relation. So ICs are downward or negatively sloped. This was the second property of indifference curve. Another property is why two IC never intersect. Important property. Separately, it is asked to prove why two IC never intersect. Okay. Suppose, let us assume two indifference curve intersect each other. Indifference curve 1, indifference curve 2 intersect at point A. Let us assume. We have to prove that these two will never intersect. And these are the other 2 points, B and C. Okay. Now, first property of indifference curve was all the point on an indifference curve show same level of satisfaction. So, in IC1, 2 points are A and B. So, whatever satisfaction you will get at A, same satisfaction you will get at B. A and B, same level of satisfaction. Similarly, in IC2, 2 points are A and C. Whatever satisfaction you will get at A, same you will get at C. Because every point on an IC, same satisfaction. Now, if we compare these two equations, what we get? We are getting B equal to C. A equal to B, A is equal to C means what? B is equal to C means what? These 2 points are same indicating here. Means what? If whatever satisfaction we are getting in B, same we will get in C. But is it possible? No. B never be equal to C because of why? C lies on the different indifference curve. Means what? Different level of satisfaction. But according to this one, we are getting B is equal to C. But in general, it is never be possible because B provide less satisfaction compared to C because B lies on the lower indifference curve. Means what? Our assumption was wrong because B never be C. So our assumption was wrong means what? Two indifference curve never intersect. This type of situation will never arise. Okay. So this is about our first unit.